In this lecture, we are going to discuss mean chart or X bar chart. This is one of the techniques of quality control, and that technique is called mean chart. Sometimes it is called X bar chart. আজকের ভিডিওতে আমরা mean chart বা X bar chart ইউজ করে কিভাবে কোয়ালিটি কন্ট্রোল ডিসিশন নিতে হয় তা আমরা দেখব। So in case of quality control, the main concern is to calculate the control limit. So for the mean chart, the control limit is given as follows. This is the upper control limit and this is the lower control limit. Upper control limit is given as this X bar is called mean of sample means. This Z is the value of sigma, and this sigma X bar means mean of the standard deviation of the sample mean. In case and so on, for the lower control limit, the formula is same except one modification. That modification is plus and minus. In case of upper control limit, we plus this deviation term with the mean of sample means. In case of lower control limit, we minus this deviation term with the mean of sample means, and in this way we get these two formula. This is the upper control limit, this is the lower control limit for the mean chart. Now এখন আমরা এই ফর্মুলাতে কিছু টার্মস এন্ড টার্মিনোলজি আছে বা আমাদের কিছু ক্যালকুলেশন আছে যেগুলো আমরা এখন ফর্মুলা ইউজ করে ইজিলি বের করতে পারবো। First of all, you have to know how to calculate the standard deviation of the sample mean. The standard deviation of the sample mean is calculated as follows. The standard deviation of the sample mean, this is the standard deviation of the sample mean, and this is equal the process mean, the process standard deviation, that called sigma, divided by the sample size, and that is called root over n. And in this way we can calculate the standard deviation of the sample mean. In the second case, আমরা যেটা দেখব সেটা হচ্ছে mean of sample means. আমাদের mean of sample means is referred by x double bar, and x double bar is equal to sample mean, first sample mean, second sample mean, third sample mean, and so on to the n sample mean, and divided by the number of samples. So these are the two formulas for calculating the mean of sample means, as we see over here in the formula, mean of sample means and mean of standard deviation of the sample mean. Before we calculate these control limits, first we have to know some basic concept, basic thing about mean chart. So these are the basic key characteristics of mean chart. So mean chart or X bar chart is sensitive to the shift in the process mean, because the reason is that, as we read over here, if the process mean shifts, the upper and lower control limits also changes. That means that if the process mean changes, in case of X bar chart or mean chart, the upper and lower control limit also changes. So that is why the mean chart is very much sensitive to the shift in the process mean. The third characteristic হচ্ছে X bar chart or mean chart is based on the normal distribution. আমরা এই জিনিসটা এভাবে দেখব। So far this is called the sampling distribution properties of the sample mean. This is the sampling distribution of the sample standard deviation of the sample mean. This is the sampling distribution of the mean of the sample means, and they are all normally distributed. So these are the three characteristics of the mean chart. এটা খুবই ইম্পর্টেন্ট আমাদের জানা, কারণ মিন চার্টের ক্যারেক্টারিস্টিকসগুলো না জানলে আমরা কখন মিন চার্ট ইউজ করতে হবে, তার ডিস্ট্রিবিউশন প্রপার্টিজ কি, তা আমরা অবশ্যই জানতে পারবো না। So far now we are going to apply the mean chart for using the following example math. This example says that we have 5 sample over here: first sample, second sample, third sample, fourth sample, and fifth sample. Then in consequences we have 4 observation in the each samples, and we also have this is called first sample mean, second sample mean, third sample mean, fourth sample mean, and fifth sample mean. এখন এই ডেটা ইউজ করে আমাদের এখানে কি ক্যালকুলেশন করতে হবে? So we have to compute 3 sigma control limits. So that means 3 sigma control limits using the above sample data. Determine whether the process is in control or not. Also it is known that the standard deviation of the process is 0.02 minutes, that is called sigma. So এখানে বলা হচ্ছে আমাদের 3 sigma control limit ক্যালকুলেট করতে হবে, and using this 3 sigma control limit আমাদের ডিসিশন দিতে হবে whether the process is in control or not, and we are also given that our standard deviation of the process is 0.02 minute. So now these are the information that we are going to use to calculate the control limits for the mean chart. The formula for calculating the control limits for mean chart is this, and we have to calculate the mean of the sample means. And so far we know we have 5 samples: the first sample mean, second sample mean, third sample mean, fourth sample mean, fifth sample mean, and this is the number of samples because we have 5 samples. If we look up or if we go above, we see that the sample means are following. The sample means, 5 sample means are these. So we have to use these following sample means to calculate the mean of sample mean, that means the value of x double bar. সো আমরা x ডাবল বার ক্যালকুলেট করার জন্য আমরা এই স্যাম্পল মিনগুলো এখন ইউজ করব। ফার্স্ট স্যাম্পল মিন, সেকেন্ড স্যাম্পল মিন, থার্ড স্যাম্পল mean, fourth sample mean, fifth sample mean, and we divide by number of samples, that is equal to 5, and this ultimately gives us x double bar, that means mean of sample means equal to 12.11. So we have calculated the mean of sample means equal to 12.11. Now we calculate the standard deviation of the sample mean. Okay, so this is the formula for calculating the standard deviation of the sample mean. This is the standard deviation of the process, this is the sample size, value of n, and this is the standard deviation of the sample mean symbol. Okay, now we go on to collect the information. Our standard deviation of the standard deviation, that means the value of sigma is this. So the standard deviation of the process is 0.02 minutes, and we are given that the sample size is 4 because we have 4 observation in a sample. So we have 4 observation in a sample. Okay, now we are going to use this data and statistics to calculate our standard deviation of the sample means as follows. So sigma x equal, as we see, sigma x, that means standard deviation of the sample mean is equal process standard deviation divided by number of samples root over of number of samples, and then when you divide, ultimately we get 0.01. So this is the standard deviation of the sample means, this is 0.01, and the value of x double bar is equal to 12.11. Now we are ready to calculate the control limits using these values. Okay, so now we calculate the upper control limit and lower control limit for the mean chart. Now the upper control limit formula is this: x double bar plus z and sigma x bar, and upper control limit is equal to, we know the mean of sample means is equal to 12.11, and then the standard deviation of the sample mean is equal to 0.01 from the above. Now where does 3 comes from? আমরা জানি, আমরা যে একটু উপরে যাই খেয়াল করি আমাদের এখানে কি control limit calculate করতে হবে. We have to calculate the 3 sigma control limits. 3 sigma means the value of z equal to 3. So we put 3, the value of z should be 3, so the value of z is 3, so this is 3. Value of sigma x, as we know, the 0.01, this is 0.1, and we also know the value of x double bar is 12.11 from the above. Once we add up and multiply, then ultimately we get 12.14. So this is the value of the upper control limit. In the same manner we can calculate the lower control limit, and this is the lower control limit, and the lower control limit says that the x double bar is 12.11. in this time we minus the same quantity 3, that's 3 sigma, and the standard deviation of say sample mean is equal to 0.01. if we minus this amount we get 12.08, and that is equal to the lower control limit. So far we have got our desired calculation. Our upper control limit is to 12.14, our lower control limit is equal to 12.08. Now we can use these control limits to determine whether the process is in control or not. Okay, now this is the, so now we can determine whether the process is in control or not. So using this control limit, as we see 12.14 and 12.08, we can draw the following picture. So this is the picture that we draw. We refer this as upper control limit. This straight line, this upper straight line is called upper control limit. This lower straight line, horizontal line, is called the lower control limit. And in between we have the process sample means over here, mean of the sample means, and this mean of the sample means is equal to, so far we know that the mean of sample means is equal to 12.11. so this is the mean of the sample means that fall in between the upper control limit and lower control limit. So we can describe this as follows: the upper control limit is 12. As we see, the upper control limit is 12.14, the lower control limit 12.08, and in between we have the mean of sample mean, that is equal to 12.11. and this upper straight line, the straight horizontal line is called upper control limit, lower straight horizontal line is called lower control limit. As we see over here, আমরা একটু খেয়াল করে এখানে দেখতে পাই যে আমাদের এই দুইটা ভ্যালু, এখানে দুইটা ভ্যালু 12.14 and 12.08, এই দুইটা ভ্যালুর যে রেঞ্জ আমরা দেখতে পাই এখানে 12.14 and 12.08, এই দুইটা রেঞ্জের মধ্যে আমাদের সকল স্যাম্পল মিন এক্সিস্ট করে। আমরা খেয়াল করি 12.10, 12.12, 12.11, 12.10, 12.12, এই all values exist in this range. That means আমরা আরেকটু খেয়াল করলে দেখব যে all data points falls in the acceptable range, falls in the control limit or acceptable range, falls in the acceptable of all data points. Since all data points falls in the acceptable range, আমাদের range হচ্ছে এতটুকু, this is our range. যেহেতু রেঞ্জের বাইরে কোনো ডেটা আমাদের এক্সিস্ট করে না, আমরা ইজিলি বলতে পারি that our process is in control. That means because all data, all sample statistics falls in the acceptable range, and that range is 12.14 and 12.08. So process is in control, and that is our conclusion. So far, using the mean chart, we have solved this math, and we have seen how to calculate the control limit and how to give the decision on the basis of mean chart using this control limit. And that's all from this video.